So hey there, today we will learn about how to find duplicates in a sorted array. Finding duplicates in a sorted array. So there are two methods. Of course, you can use the brute force approach, but today we will discuss about these two methods. So first is of course, let me first create an array. So let's suppose there is an array which has approx 10 elements, right? So 0, 0, 1, 2, 3, 0, 5, 6, 7, 8, 9. Okay, so there are approximately 9 elements. So let me just reduce this size to somewhere around this. Let's insert the elements of 3, 6, 8, 8, 10, 12, 15, 15, 15. And the last one is 20, right? As you can see, we have done the indexing and all. Now the first method that we can use for finding duplicates in this sorted array is of course using, let's suppose there's array name is A, right? Now what I can do, I can if A of I double equals to A of I plus 1, right? A of I plus 1. If A of I double equals to A of I plus 1, that means it's a duplicate value, right? So according to our logic, what we can do, we can store the last duplicate, right? We can store a last duplicate in an array because here you can see that there are 3 repetitions, right? So 15 is repeated 3 times. So if I use this method, which is A of I equal to A of I plus 1, A of I, if A of I is here and I do A of I plus 1, it will say it's a duplicate, right? And after that, I will be plus plus, which means it will go on this, and 15 will be printed again, which is not correct, right? We just need to find the unique elements which are duplicates, right? So what we will do, we will store a variable named last duplicate. Okay, when we store last duplicate, so last duplicate will contain, just a second. So we will store last duplicate. What it will do, wherever our A of I is, and if A of I is double equals to A of I plus 1, so LD, which is last duplicate, will get updated with the current value, which is 15, right? And we will also insert a condition that and A of I is not equals to LD, which is last duplicate. Only then it will enter that if condition and print our number, which means it won't be printing 15 more than one time because it's in continuous sequence, right? It's a sorted array, so it's in continuous sequence. So it won't get printed 2 times. Now let's come to the logic. If you see it, logic would be, so we will have a for loop. Why it's not working correctly? For loop I equal to, I will start from 0, I less than n, I plus plus, right? Inside I, we will have an if condition, which will be A of I double equals to A of I plus 1, and we will also add an end condition, which is for not printing same element more than once. So A of I would be not, if A of I not equals to last duplicate. So what we will do, we will print it, right? Printf or whatever console log you want to use, you can use. So %d / for line break A of I will print A of I, and last duplicate will be updated, right? So last duplicate will be A of I. Okay, so this is our logic. This will run and we will get printed. Of course, last duplicate variable we have to declare and store it. Like we can keep it as 0 for initial, as an initial value. Okay, so this was the first method of finding duplicates in a sorted array. Now let's come to the second method. Okay, so let me create that array once again. Okay, just a second, give me a second. So let's fill this array. First let's give the indexing. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, 1, 2, 3, 4, 5, 6. Of course, the elements should be same. 3, 6, 8, 8, 10, 12, 15, 15, 15, and the last one is 20, right? The second method, what we will do, we will use 2 pointers, I and J. So we'll use I and J. So let's suppose I starts from 0, right? So J will start from I plus 1, which means I is here initially, but then it comes here. J will keep on moving until I is equal to J. So I will be here, then I will come here on second index, I will be here, j will be here, j will keep on moving. If I is double equals to j, only then we will create a while loop which will make sure that j keeps on moving until it's same with I. E of I, right? This is the E array. So 8 will get printed, right? Now if j will come here, right? On this fourth element. Here I and j won't be same. So what we will do? We will start I again from, so we will update the value of I to j minus 1. It will be this, right? J minus 1, which in this. Again it will check, okay? J minus 1. Again it will check if it's equal to same. It is not. It will move to the fifth element. I and j both will keep on moving. Then I will come here. J will come here. Then j will keep on moving until it's same with respect to I. 15 will get printed. Then then j will come here. Now I and j are not same, which means we will update position of I to j minus 1, which is here. So I will be here and j will be here. Then we can see that it will be end of an array, which means we will stop this loop. Now what will be the logic around this? Logic is pretty simple. Okay, one more thing I forgot to tell you about is the time complexity for the previous approach would be order of n, right? We go of n because we are traversing only once through the elements. Same goes for this. In this logic also, the time complexity would be big O of n. Now the logic, right? So what we will do, we will start with a for loop. I equal to 8. So I equal to, I will start from 0. I will keep on moving until n minus 1. N is the length of array. I plus plus, right? Now the if condition that I was talking about is E of I double equals to E of I plus 1. Push again I plus 1, then only we'll move to this, and j will start from I plus 1, which means j will of course start from 1 point ahead with respect to I, and then we will have our while loop which will make sure that it keeps on moving until the values are same. So we don't get like 15 is repeated 3 times, right? So we don't need to print it 2 times. Okay, so E of j double equals to E of I until what we will keep on doing is we will do j plus plus. We will keep on moving g, and we will print it. Printf what will print? We will print E of I, and how many times it got repeated? J minus I, correct? Whatever the index will be according, like if j is 6 and we have I at let's suppose 5, then 5 minus 6, 1 or 2 times or whatever it is, right? So j minus I will j will be ahead of I. So let's suppose j will be 7 and I would be 5. So 6 minus 7 minus 5 would be around 2. So it repeated 2 times. This is the number of repetition. This is the actual element. So I would be, we will update I to j minus what, because we want to make sure that we don't start from the next element where the I was earlier, because we have already counted the duplicates, right? So this is the logic around this. So yeah, that's it. So this will of course be off, and will be the time complexity. Space complexity will be constant because we are not utilizing any extra space. Same goes for the earlier one. So yeah, that's it. So yeah, there is one more method of finding the duplicates in a sorted array using hash set. So let me just write it first. Hash map, or you can say bit set, right? So we can use this method as well. Let me copy the array first. Like I erase this. The array will be same. Let's give the indexing 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now what we will do, of course, you might know how we create a hash map. We take the largest value in an array, which is the last element of an array, because this is a sorted array. So we'll create an array hash map of size 21, because we also need 20th element, right? Let me create that. Okay, now 0, 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. The array got bigger, but yeah. So initial value for all will be 0. Now what we'll do, we'll loop through this array and make sure that we'll create a for loop which will traverse through the array, and we'll update that value in our hash function. So let's suppose it will go to the first, I will move to the first element, and we will check and update it to 1. Now on the first element it was 0, so first element would be 6, so this will update. 8 will update twice, okay, because it's 2 times. So we'll make sure that h of e of I, whatever the value is, was keep on increasing it, right? So it will increase 2 times, then comes 10 will be 1 time, then comes 12 will be 1 time, then comes 15 will increase 1, 2 and 3 times, then comes 20 will be 1 time, okay. Also we will make sure that lowest element is 3, right? So we'll store it, we will start our I from this to make sure that it does not takes extra amount of time for this extra values. Now lowest element is 3, we will start counting from 3, and we will check if any index has value more than 1, we will print it, which means it has been repeated more than 1 time. The element has been repeated more than 1 time. So what we will do, we will traverse through this hash map, and so it will get printed. Then we will go, we will see this is 1, this is 1, this is 0, this is more than 1, 15 will get printed. So on print values will be 8 and 15. Also you can print how many times it got repeated using this value, right? Using h of I, or let's suppose j for that loop. So we can also print that. So yeah, this was using hash map. Logic would be pretty much same. You see, logic would be, there will be a for loop. Okay, there will be a for loop. What do you do for I equal to, we'll start from 0, I less than n, I plus plus, basic. Okay, and of course h of e of I will increase the value. That's it. So this is how we'll do it. And the second for loop. So second for loop would be I equal to 0, I less than equal to h dot length, h dot length. Of course, here we can also make sure to use lowest element just to not start from 0. But yeah, that depends. You can utilize, you can optimize the solution. And after that, we will have an if condition. If h of I is greater than 1, only then we'll just print I and h of I. Okay, I will give the actual number, h of I will give number of times it got repeated. So yeah, I think that's the solution we have on finding duplicates in a sorted array. So yeah, that's it. Thank you.